Okay, today we are going to be looking at 9-6. We went over a big discussion and kind of a proof as to why this happened in class. I'm not going to get into that into the video, but if you're interested, you can see the book or come see me. What we discovered today is the measure of an angle formed by two chords that intersect inside a circle is equal to half the sum of the intercepted arcs. So the angle we're talking about here is angle 1. The intercepted arcs are AC, you can see I've outlined in blue, and DB. So if I was finding the measure of angle 1, I would add the measure of arc AC and the measure of arc BD, and then I would divide it by 2. In the next one, there we go. The measure of an angle formed by two secants, two tangents, or a secant and a tangent drawn from a point outside the circle is equal to half the difference of the intercepted arcs. So again, we're looking at angle 1 here, and in class we did discuss why this happens. So angle 1 is half the difference of the intercepted arc. So as you come out across these two secants, you see it intercepts an arc here at BD and an arc here at AC. So angle 1 is going to equal half the difference of AC minus BD. Here I have a little summary page for you. We've discussed angles in the circle and their relationship to the arcs for several sections now. So if the vertex of the angle is at the center, that's a central angle, the arc was equal to the angle. If the vertex of the angle was on the circle, that's an inscribed angle, and we studied those over the past 2 days. The intercepted arc is equal to twice the angle. Okay, and then these next two are the ones we did. If the vertex of the angle is in the circle but not the center, then the angle is equal to half the sum of the intercepted arcs. This actually does work if it's at the center as well. You just don't need it. If the vertex of the angle is outside the circle, then the angle is equal to half the difference of the intercepted arcs. Okay, so what I'd encourage you to do is to copy these or use your notes that you printed out to follow along. Give these a try yourself, okay? Try them for yourself and then come back and I'm going to explain them, but it makes more sense and you learn more, even if you get them wrong, if you at least try and see what you can figure out and see where your questions may be. If you have a question I don't answer, please just write it down in your notes and come see me. Okay, so push pause now and give it a try. All right, so coming back in, I'm going to start with angle 1. Angle 1 is here, and I notice that the vertex is in the circle, not at the center. So it's equal to half the sum of the intercepted arcs. So if I come over here, angle 1 intercepts this arc, and if I go the other way, the chord intercepts these arcs. So angle 1 is going to equal 1/2 of 70 plus 50, and that equals 60 degrees. Now I'll go to angle 2. Angle 2, I look at the vertex, it's outside the circle. Okay, here's the vertex. So it's equal to the 1/2 the difference of the intercepted arcs. So these secants are intercepting arc BD here and this arc EC here. So to find angle 2, I'm going to take half the difference of the intercepted arcs. As we move down here, when we talk about a point of tangency, with the tangents, that's kind of the point where the arc breaks into two separate arcs. I'm going to start with finding BD. For BD, I looked at the 100-degree angle, which is here. Vertex is in the circle, so it's half the sum, sorry about this, the intercepted arc, this one and this one. So I know 100 is equal to half of, I'll call this X. Sorry, that looks like a plus sign. X plus 66. So I just kind of wrote it out for you. Angle BOD is equal to half of arc BD plus arc CE. I plugged in what I knew. From this step, I just doubled the 100, multiplied both sides by 2, and solved. So I got X, or arc BD, equals 134. To find our arc BC, Oh, I'm sorry, I have the wrong thing here. Sorry, guys. BD. The 40-degree angle outside, so it's half the difference. One of your arcs is here, BC. The other arc, I'm just going to put it in a different color so you can see where it breaks, is from B to D. That point of tangency is where the division of the arcs happens here. It's outside, so it's half the difference. I now know what the value of x is. X is 134. And I'll call arc BC Y. So I put the 134 in for the x, that green arc, and then again I solved it, and I got that y equals 54. In the next ones, again, I would try, I can hide these for you if you're, try these yourself. Okay, push pause, try them yourself, and then come back. Okay, again, here I'm looking at angle D. The points of tangency are where the arc breaks up. I was told AB right here equals 105. That was given. And I see that arc AB and arc ACB make an entire circle. So to find arc ACB, the major arc, I just subtracted. And that's how I got angle D. In this one, arc AB, it's a similar one as we did before. 10 is outside the circle, so it's a difference. Doubled both sides and solved. I got arc AB equals 40. All right, this next one's a big one, and you're finding angles 1 through 8. 2 isn't an angle, it's actually the arc measurement. This is important information you're going to know. So take a moment, push pause, fill this in. This is kind of reviewing all of your angles at once. So I'm going to ask you again, please push pause and work through these problems yourself. Okay, over here I have your answers. Angle 1 is a central angle. I knew it told me AF was a diameter, so I know arc AF is a semicircle. So if this arc is 100, this arc's 80, that's your 2. Angle 1 is central, so it's an 80-degree angle. Angle 2, or I talked about 2. 3 is inscribed, vertex on the circle. It intercepts arc CF, so I did half of that arc. Angle 4 is made of chords, half the intercepted arc, so 80 is coming from here. The 155 is coming from arc EA, because if you follow the chords, that's what's intercepted. Okay, angle 5 is a similar. It intercepts arc, the 25-degree arc and the 100-degree arc down here, so it's half the sum. Angle 6 is outside the circle, so it's the red are given. 1/2 the difference of the intercepted arc, so as I follow the sequence out, this arc down here is the 100 minus the 30. Angle 7, there's a couple ways to do this one. This is actually a radius and a tangent, so you should have known it was 90. But you can also look at the intercepted arc. It goes from the point of tangency at A around to F, so it's half of 180, which is 90. Angle 8 is also made of a tangent and a secant. It is the arc intercepted goes from A to C. That's a 125-degree arc. It's half of that, which is 62.5. Again, you may need some time, or if you have any questions, write that down and you can come back to me on that. Check for your homework assignment, and that's the end of